P3-22 is another instance where we can utilize our contours and regions and generate our shapes and then share the sketch to create this this geometry. So issue with the tolerance is not the 11/16, the 0.69, is that this 0.63, the 5/8, is an interior geometry. So even if that's the critical dimension that we want to hold, being on a arc, it's going to be fairly difficult to inspect and measure. But at the very least, we would make this edge a reference dimension so that it is measurable, and or reverse it and come back. So that was one that we'd have to review on the tolerance side. So shape-wise, I would like to have this on the midplane because then it makes it a little easier to cut the geometry based on what we're given. All right, so I'll fly that out of the way. This is an inch part. Be on the front plane. We have a height. I'm going to go ahead and stay with the rectangle. So 2.5 inches. And mainly I'm staying with the rectangle because the 2-inch radius on the left shows it to be at the intersection of this edge and this edge, which the rectangle conveniently gives me. So 3.88 on the length. This is also where we may want to consider, do I need to take this out to 3 decimal places? I know I've mentioned this on other videos, but seeing the 3 decimal places and the 3.88, do we want to let that be the rounding, or actually come up with the geometry? All right, so the 2 inches, I'm going to go into the circle, and a radius of 2 would give me a diameter of 4. The back to the step to the radius. All right, so that'll be tangency. And then I can connect it, and that arc, control select the edge, will be tangency. We have a dimension to the center of 0.63. So again, 5/8 would be 0.625. You can see just a little bit of a gap there. What do we have for a distance? Okay, so 1.25. So here's where that stack up actually comes into play. If I put a dimension on this radius, I'm going to see 0.62. Well, if we were trying to center that radius or create the geometry, then 0.625, 0.625, well, we've created a fundamental shift there. So I'm going to hit escape a couple times so that I can connect the dots. So that's one I'd want to take a look at because the rounding is affecting those 2 dimensions. Let's see, what do we have for our step? Is an inch. So here's an instance where I'm looking for the intersection. Well, I could pick up the midpoint, but that's not really helping me. So the point is a good option here. We don't get to use points very much, but if I put that at the intersection of the circle and the top edge, then that gives me something that I can dimension to. Okay, so 1 inch, and that gives me the shape. And we'll go with the 1/2 inch diameter, which is 1.13. All right, again, looking at this from the standpoint of, yes, we have 2 decimal places, but we can shift 5 thousandths to be at, oh, missed that one by just a little bit. We can shift by 5 thousandths just within our tolerance zone based on the rounding error. So let's try that again, 1.13. That looks a little better. And so if we take the stack up of the 0.62 plus the 0.88, it still works out to be a nice even number, but really is it the intent that we have for the part. So we're designing for convenience. I would say that in industrial commercial applications, we're going to take this to 875, 1.125, 0.625, and 3.875. And then let the stack ups in the drawing say that this can be a 2 decimal place, but let it round and be technically in the correct position. All right, so extruded, and contour that we're going to pick is that one. Oh, and I missed a couple pieces of geometry. So let's see what happens if we go mid-plane and we have a distance of 2.38. I have the shape. All right, so if I decide I want to include that other geometry and make this a shared sketch, I right-click, I go back into the geometry, go into the sketch. We go from a location to a location. All right, so the advantage of doing this is the 0.63, our 5/8, is easy to dimension. 0.69 is not really much of an issue, but the 11/16 portion of that, 0.6875, now we have 2.5 thousandths difference between our round and our nominal. All right, so if I go ahead and accept, let's see what that looks like. All right, cuts it off. That's not exactly surprising. So when I go back in, I'm editing, and I need to include the additional 2 regions to make sure that it generates the geometry. Oh, that was interesting. All right, so let's try that again. Edit feature. It picked up the contour somewhere, so it included that in the selection. All right, so we're always going to verify and check that it created the shape. Now I need to do an extrude cut with the same sketch. The contours are going to be the interior shapes, and I'm going to give that a mid-plane. The distance for both is 0.75, and we can accept that geometry, and that will generate our shape. All right, so the issue here, 0.709. Again, not necessarily a nominal number, but a usable number. All right, so based on the way I selected, I could have drawn that in the right plane. Let's call this good, but the experiment here will be to switch the sketch plane. All right, something it's going to be much easier. I decided it's going to be easier to bring it into the drawing, bring it into the assembly. We have this icon on the right mouse button context that is edit sketch plane. Right now it's showing it in the front. If I move this around to the right and switch the sketch plane, it's going to rotate the part. I have just as much chance that it would rotate the opposite way, depending on the selection, and not give me a desired result. So sometimes the changing the sketch plane can produce more than it's worth. So let's go ahead and save. And this is our 22. And we're ready to, so this finishes out the assignment. The next couple will be optional, and at this point we can gather all of those up and turn in the assignment.